Welcome to a new video from KÖCO, here from the metal and steel construction sector. Stud welding gun. At first glance, it looks pretty simple, but how do I actually set up this stud welding gun? And there are always some confusions, for example, when it comes to the lift. What is the lift for? The lift? We all know that a stud welding machine is a constant current machine. If it's supposed to deliver 2000 amps, then it will deliver 2000 amps. But how is the voltage defined? Welders know that the voltage is always defined by the length of the arc. How high, how long the arc burns. Not the time, but how long it burns. And that's why we have to, as the fourth parameter in stud welding, always set the lift. A small stud like this might get by with 1 millimeter or 1.5 millimeters of lift, like an M8, and a large M24 or even a 25 millimeter head stud, that one already needs more than 5 millimeters of lift. Yeah, but how do I set the lift? That can be very different depending on the gun. So let's start with the smallest gun, an SK14. That's the name of this gun, and right now it's equipped for a threaded stud. And you can easily see on the back of this SK14, there are two holes. These holes are intended for a screwdriver on one hand, and on the other, I see a scale there. It currently reads 3.5. What does that mean? It means that when we operate this gun, when we trigger the welding process, it lifts by 3.5 millimeters. Now, this SK14 has a peculiarity that other guns don't have. If I now insert a stud, and let's say it protrudes by 1.5 millimeters, and I want it to lift by another 2 millimeters. So I press this down here, push it down, and then the machine lifts up. Now it doesn't lift the 3.5 millimeters shown here, but instead it lifts 3. Now it doesn't lift the 3.5 millimeters shown here, but instead it lifts 3 millimeters from the starting point of the stud. So when the stud welding gun is completely unloaded, this gun does not have any length compensation. That means with an SK14, whenever the letters SK are in front, you always have to add together the lift and the protrusion of the stud. So with 1.5 and 2 millimeters, that would now be 3.5. If I only have a 1 millimeter protrusion and a lift of 1.5, then I would set it to 2.5. I always have to add that up. That's not the case with most guys. This here is a classic pistol, which is the most commonly sold type. And these pistols have a lift compensation. That means if I have a 4 millimeter protrusion and also want to lift by 4.5 millimeters, I don't set it to 8.5, but actually to just 4.5. These pistols are called K22. K22D because it also has a damper. We'll get to the damper later. But with the K22, K24, and K26, it's the same everywhere. These pistols have a lift compensation. That means even if the bolt length varied by a millimeter, which it won't because the bolts are manufactured very precisely, but if it did, the pistol would compensate for that length difference. And it always lifts exactly what I've set it to. Now comes the first objection. I hear this a lot on the phone. At our company, with our pistol, you can't set it so that the handle is all black. If you take a closer look, you'll notice there's a protective cover. I unscrew this protective cover, and underneath I have these two holes as well, just like on the other one. So how does it actually work inside the pistol? Inside such a pistol, there's a magnet, which I brought along to show you. The magnet is electrically controlled. Then it moves, the core of the magnet moves upward, and a small pin comes out at the top. And I limit this pin with the help of a brass disc. You can see on the brass disc, on one side there's a scale, and on the other side there are holes. These holes have different depths of drilling, in this case from 1.5 up to 4.5 millimeters. and it moves on top here, and then the magnet only lifts as far as the depth of the hole allows. I just said that you can adjust the stroke on every pistol. Not always. Maybe that statement was a bit premature, because there is also a third type, the so-called KE pistols, electronic pistols. I can't adjust the stroke on those. The stroke is set on the machine itself. You can recognize these pistols first because it says KE electronic on them, and second because they have a 7-pin cable instead of the usual 4-pin connection cable. Conventional machines can't do that. They usually only have this 4-pin connection, so they control the magnet, just like I showed you. The magnet lifts, the magnet releases, and the bolt is pushed into the bath by a spring. And with a K-Kai pistol, it's different. Like with a Tiger, for example, which is a very modern machine. It can control these pistols. It measures the stroke precisely. I set the stroke on the machine. The machine adjusts the stroke exactly as it is set there. How do I set the stroke on an ELO Top Plus with a K pistol? I go to the menu, parameter settings, and then I can use the buttons here to scroll forward to the stroke. The stroke is now set to 4 millimeters. I can change it here to 3.5, for example. Then I save everything, go back. And that's it. Now the machine makes a stroke of 3.5 millimeters. I can set it again. Menu, parameter settings, enter. Stroke 3.5. We go back to 4 millimeters and save everything. And then go back to our welding parameters. That a KE pistol is connected, we can see down here at our pistol display where it shows 0.0 millimeters at the top. This is now the 0 position of the pistol. And if we had placed a stud on now and moved the whole thing, we would see how it changes. With this function, of course, we can also easily set the projection. Now we insert the stud and align the ceramic ring. And when we press the stud down before we want to weld, we would now see, for example, 3 millimeters would be the stud projection. And from that point, from those 3 millimeters, it will then lift the additional 4 millimeters that we set earlier. On the diagram, we can later see very precisely when we evaluate this weld, because this machine stores all welds, including the lift, that is, the current, the time, and the left. Then we can see exactly how the stud is lifted from 3.5 millimeters, or 3 millimeters, which it was protruding by. Then it lifts up to 6.5 millimeters, and then goes down to 0. 0 because it dips into the bath, and that's where we form our bead. It's actually a really great thing with these KE guns. It works extremely well. Yes, and finally, the biggest gun in the whole series, the K26. So that was the K gun, and now we're back to a K gun. And this one doesn't have a cover, so you can adjust the lift directly at the back. So what else can we adjust on a gun like this? What else do we need to adjust? And this is really important, the centering. As you can see here, I've loosened it up a bit, and now the whole thing is really wobbly. This has nothing to do with manufacturing tolerances. No, that's intentional, because now we're going to insert a bolt into this bolt holder, place a ceramic ring on top, and then center it so that it's perfectly aligned in the middle, so the bolt can move through the ceramic ring without touching the ceramic ring. And that's why the whole thing has these elongated holes. Center it, and then I tighten it up. And then it fits. And then you can test it with an air shot. If it goes through cleanly without touching or lifting the ceramic ring. So that's where I set the centering. What else do I need to adjust? We can see it at the bottom edge. On these two screws, sometimes they look like this with wing nuts attached. That's where I set the length of the bolt. I insert the bolt, Take a ceramic ring and then here, set the protrusion exactly as specified in the table. And then I just tighten it. And because I centered it properly beforehand, it now goes through without getting stuck anywhere. So what else can you adjust on a gun like this? Basically, nothing else. Some people might say the damping. A gun like this has damping. What is the damping of a gun? We can see up front here, there's a shock absorber. Why do we need damping? The magnet pulls the bolt up, the arc is maintained, and then a spring and the weight of the bolt press it into the weld pool. Now, of course, it can happen that with a large bolt and a very high lift, it would plunge into the weld pool very quickly. What happens if it plunges into the weld pool quickly? It splashes massively and the whole thing falls apart on us. The weld pool, the weld bead goes everywhere because we're just plunging in too fast. That's why these dampers exist. This is what the thing looks like. I took it out once. These dampers are adjusted, but they're not adjusted by you, the operators. These dampers are preset at the factory, installed in the gun, and under normal circumstances, you should never adjust these dampers. The dampening of the gun is set permanently. That's why I would just ignore this parameter for now. So to sum up, on the gun, we adjust the stroke, the overhang and the centering. So thanks again from the steel construction department here, and we'll see each other in the next video. And if you have any more questions, just get in touch at www.KÖCO.net or just give us a call. Our staff will be happy to help you out. Thank you.